So I think everybody has got the message through Gmail, Google Classroom, correct? Only 16 students are there. Okay, let us start with what we have learned from in the class. We have started with unit number 2, consisting of constraint devices and constraint networks, and different properties or the parameters which are causing the network to become a constraint. There are number of limitations that happen in the network. This is because of the choice of the devices that we select in order to build a network. And what people have done, they have classified the networks into different categories. So whenever we talk about IoT, we are only talking in terms of the wireless communication and how the IoT boards are connected and a network is formed. So you need to remember that the fundamental thing, whatever data we pick from the sensor, it has to be interfaced with the IoT board, and after that this IoT board is going to divert the packet towards a gateway, a common point from where all the IoT boards are going to exchange the information towards the network. Beyond that common point, we are going to use a network which is in already existence, which is called as a infrastructure network, or in many books it is given as a backhaul network. So I can broadly classify the IoT networks depending on the coverage area, whether the technology that I am using is IP based or non IP based, or the most generic approach is to have a classification of the technology on the basis of frequency, whether the spectrum that I am using or the frequencies that I am using, is it licensed or is it free. So many books, they have only given in terms of licensed and unlicensed, or otherwise IP based or non IP based, but in our case we are focusing on the coverage area. So I had given you the broad classification in the class. I can classify the technologies that are used in order to form a IoT network can be classified on the basis of the coverage area, whether the network that I am developing is going to be in the coverage area of 100 meters. I can have two classifications. One is your LAN, or sometimes it is also called as, in our case, Wi-Fi. The coverage area is 100 meter. The number of devices that are exchanging the information and forming a network will be in the range of 100 meters to 150 meter. Okay, these ranges that are given, I have taken it from internet. These are not the absolute ranges. They may change according to time, and here on the y-axis, B has to be assumed as a bit, not a byte. So the maximum packets that I can transmit in a coverage area can be also considered as a parameter in order to classify the network. Again, the frequency ranges, again the second classification that we are interested in learning is called as personal area network, in which the technologies that are used in order to form a network are your Bluetooth, ZigBEE, Z-Wave, wireless HART, that is in your syllabus. Even -7 is used here, but it is overlapping with two different classifications. Similarly, we are having the cellular network, which is already present in the market. The technology is very popular, hardware is available. Only thing is that you need to interface your IoT board with that particular network, and it can be used for sending the information to the cloud. So over a period of time, people have also developed the technology specifically for IoT. These are called as low power wide area network. As the name suggests, wide area networks they cover a distance starting from 150 meter or 500 meter and up to 10 kilometer. So cellular and this low power wide area network, these technologies they are used to cover the distance more than 10 kilometer nowadays, up to 15 or up to 50 kilometer, depending on the technology that is used, whether I am using a cellular technology or whether I am using a low power wireless wide area network. Okay, but the bit rate will change dynamically, few kilobits per second in case of your low power wide area network, and in terms of cellular you can get the speed up to 2 mbps per second. So let us start with the very first technology, which is the personal area network. Here we are considering the range between 1 meter to 150 meter, and the technologies that we are interested in learning are Bluetooth, IEEE 802.15 standard, and more appropriately 802.15.4. This is a standard in which the frequency range is 2.4 gigahertz. So all these technologies they had used the unlicensed frequency or a spectrum that is free for use in terms of what we called ISM, industry, scientific and medical equipment, or the development of the product which can exchange the information in this particular frequency range. So out of that, in the class we have started with the Bluetooth. Bluetooth can be classified into two categories for the purpose of our syllabus. One is called as Bluetooth Classic and second is called as Bluetooth Low Energy. Deliberately I have not put there the numbering since we are only interested in learning the more generic cases of Bluetooth. Again, the topology on which the Bluetooth work is point to point, means one device exchanging the information to another device, point to multi-point, one device exchanging the information with multiple devices. And now in case of BLE, we are focusing on the technology which is called as the mesh specification. So one need to remember that whenever we say mesh specification will follow the rule like this. You are going to have the devices connected in this fashion. I think you know very well about the mesh topology. However, out of all the technology that we are going to learn, one of the topology that works is fully connected topology, correct? The majority of the topology will follow the rule of mesh, star or tree. The network will be formed in this fashion. However, few of the wireless communication technology they also follow the topology which is called as the fully connected topology with advantages as well as disadvantages. So in the class we have covered the basics of Bluetooth. So generally in the Bluetooth there are number of events that are transpiring simultaneously. So I had given you the example in the class. If you are having a Bluetooth speaker and if you want to connect it to your mobile phone, in that case your Bluetooth speaker, whenever it is turned on, it starts sending the frequency in the close vicinity of 100 meters depending on the technology that is used. In our case, if we are considering Bluetooth Classic, the range will be 10 meter theoretically, and in case of Bluetooth Low Energy, the range may start from 1 meter up to 150 meter. So once you turn on the Bluetooth speaker or a Bluetooth headset, it will start sending the advertiser packets that I am the Bluetooth device, I am having this much ID and I am interested in connecting. Second type of device, it is called as a scanner. Generally it is a mobile phone in our sense. In the sense of network, it can be a master or it can be a second Bluetooth device. So a scanner may have an intention to connect or may not have the intention to connect, but it will receive the advertising packet. It will extract the information from that particular packet. Generally, the packet that is transmitted by the advertiser, it is consisting of some payload, okay, and it is generally called as PDU, protocol data unit, in which it gives the information about the frequency on which it wants to get connected to the network, as well as the device ID, whether it is a Bluetooth headset, scanner, printer, etc., etc. So a scanner is a device which is having a intention, or it may have no intention to connect it, but it will catch the advertiser packet, and from that it may extract the information. So once the scanner scans the device, knows the information about the device, it may also be interested in connecting to the device. We call the process as a formation of connection. So if it does it, the same device scanner will be called as a initiator. Not all scanners are going to connect to the network. Only the device which is interested in connecting after receiving the advertiser packet will be called as a initiator. So same device can be a advertiser, it can be a scanner, or it can be a initiator. However, our basic topology of IoT follows that there are some nodes, and there is a common node which is called as gateway or a router, through which the packets are transmitted to the backhaul network. Again, there are number of events that occur simultaneously. First event is called as advertising. Second event is called as connecting or paging. That happens in the case of the Bluetooth Classic. In the case of Bluetooth Low Energy, there are two more events. One is called as periodic advertising, and second is called as extended advertising. So what happens in the case of the classic Bluetooth is that the device which is interested in connecting, it starts transmitting the packets. Okay, so we call that packet as a advertisement packet, and the prime intention is to tell the nearby devices that I am present here and I am wishing to pair with you. The second event is called as connecting, or it is called as a paging. So this is simple event in which the two devices are interested in connecting. So one device is called as the master in that case, and second is called as a host or device to device. In the case of the Bluetooth Low Energy, the advertising packets may be transmitted periodically after a period of 7.5 millisecond. Okay, so it simply sends the packet, advertising packet, and saves the battery, and after that it checks if any scanner is ready to have a connection. In that process, the connection can be initialized. The fourth event is called as extended advertising. It occurs in the case of what we say advertisement chaining. So if you are having 2 or 3 or 4 Bluetooth devices which are sending the packets, all these packets can form a chain, and that particular chain can be sent over a single payload. Okay, generally it happens in the case of the cluster network, in which number of nodes are interested to form a network and connect to a common master. So that common master should understand how many nodes are there, and whatever packets are received, they form a chain. You might have also learned daisy chaining in the case of the networking. So they form a chain, and that chain is received by the scanner, and such type of advertising generally happens in the case of audio or the multimedia transmission. Okay, so most of you might be using the Bluetooth headset, and you might be simultaneously receiving the audio from the device. So earlier classic Bluetooth, it won't support the audio. So in the case of the Bluetooth Low Energy, the chaining helps in what we say propagating the audio signal on the device. Again, we have seen in the class a scanner, once it receives the advertisement, it will initialize to get a connection. That connection is can be done with a node. Once the connection is formed, which is called as a paging, we say that a connection is established and a network is formed. A network can be consisting of a single node, or it can be consisting of multiple nodes. In the case where the advertiser gets connected to the scanner is called as a master, okay, and the slave is called as a simply a slave, or a node is called as a slave here. Again, there are number of possibilities. The network that is formed in the case of the Bluetooth Classic, in which the range is theoretically 10 meter, it is called as a piconet. Pico stands for 10 meter range, and whatever slaves are connected to a network, they will form a piconet. Depending on the distance and how the channels are propagated, information can be transmitted to a common master. No node can directly communicate with each other, most important in the piconet. Okay, they may form different topology. However, practically it is not possible that one slave can communicate with another slave. It has to be routed through the master itself. So same rule is there for the IoT. Whenever the nodes wants to communicate in a network, everything should go to a common gateway or a common point from where the packets will be routed to the network. So a common point can be shared between two different piconets. Okay, piconet 1, piconet 2 and piconet 3. The common point, when the two piconets are joined by a common point, the common node can be either a slave or a master. In that case, it is called as a scatter net. This happens in the case of classical Bluetooth. So again, the advertisement that is sent and the piconet that is formed depends on the addressing scheme that is used in the Bluetooth technology. In the case of the classical Bluetooth, the piconet uses 3-bit addressing. So 2 raised to power 3 will become 8. So 0 to 7. So I can have a piconet that is formed or comprising of total 8 nodes, out of which one node will be acting as a master, and there will be total 7 slaves. Correct. Similarly, in the case of the Bluetooth low energy, you are going to have the addressing scheme that is used in order to address the total number of slaves. It will be of 24-bit, and the total number of slaves that can be connected with a master will be in millions. Most important thing, you need to remember that the total number of slaves that can be connected to the BLE technology will be 1 slave per master. Correct. Instead of 7 slaves per master, in the case of the BLE, a single slave connected to a master forms a piconet. So the nodes in the piconet may be classified into different categories. Either it can be a master, it can be a slave, or it can go into standby. Okay, if it is not used, the master can direct the node to go into the standby and periodically wake up to check if there is a packet or the information which it wants to exchange, or otherwise the master wants to deliver. The fourth mode is called as the park mode, which was present only in the case of Bluetooth Classic, which is now removed in the case of Bluetooth low energy. In the park mode, the device or the node totally go into the deep sleep mode. Deep sleep mode to save the battery power, and whenever there is a requirement of the node to be connected, it has to be wake up. So standby mode is the default state for a device. Whenever the device is not communicating, it may go into the sleep mode, or we can call it as a hibernation mode, and whenever it is having some information, it will wake up and send the information to the master. So such type of node is called as a standby node or a standby mode that is used. The prime purpose is only to save the battery, because these networks they are battery powered. So these are the example of classical Bluetooth Piconet, how it is formed. And as I told, in the case of BLE Piconet, each slave connected to a master forms a Piconet. So there are millions of Piconets that can be formed in the case of the BLE Piconet. So nowadays you can see that the two Bluetooth speakers can be paired with each other. That is practically possible, and they can be connected simultaneously to a single master. We call it as a dual pairing. Okay, or most important thing, it may or it may not form a secure connection. So how the Bluetooth Classic works, we call it as a working principle or the operation of Bluetooth Classic. It occurs in the 3 steps. The first step is called as inquiry. In the inquiry phase, there might be 2 possibilities. The 2 Bluetooth devices are never connected with each other. If they are connected, we call them as a bonded, already connected. So it becomes very easy to have a trust with that device, and we can have that particular thing connected. So the first step is called as inquiry, in which we assume that the 2 Bluetooth devices are never associated or bonded with each other. So the first step will be to discover the Bluetooth device that are available. So if the first Bluetooth device transmits the advertising packet and the second device listens to it, and if it is intended in order to have the connection, it will send the Bluetooth receiving address to the what we say scanner. The second step is called as connecting or paging, in which the connection is formed between the 2 Bluetooth devices using the Bluetooth device addresses. So here the PDU, protocol data unit, in which the information is transmitted, plays a critical role. Correct? It will have information about the address of the Bluetooth device which is interested in making the connection or a Piconet. The third step, it is called as connection. So the connection, once the 2 devices are connected together using paging or connecting, we call that the connection is established, or we say that a bond is formed between the 2 devices. Correct? And now in the network, they may have different working modes, or we call it as a connection state. One is called as active mode, in which the device is in operation and transmitting the data from one node to another node. Second is called as the sleep mode, which is called as a power saving mode. So in this case, the device goes to the standby mode, or it goes into the sleep mode to save the battery, and wakes up at a particular time period in order to transmit or receive the packet from the master. This mode is called as the snipping mode, or it is simply called as the snip mode. The third mode, it is called as the hold mode. So it may happen that certain nodes they wake up at a particular time very fast, and the master don't want to communicate with them, so it will ask that device to remain temporary on the low power mode and listen only when it has been asked to do. Correct? So that device will go into the mode which is called as the hold mode. So if the master is handling millions of devices, in the case of Bluetooth low energy, or in the case of classic, it can ask the device to go into the power saving mode, and I will ask you to send the data when it is required. Such type of mode, it is called as the hold mode. So in the Bluetooth Classic, there is another mode which is called as the park mode. Here I have not written the data for it. It is called as a deep sleep mode. Okay, it was present in the case of Bluetooth Classic, in which to save the battery, the node can be asked to go into the deep sleep mode, operate in a very low amount of current in microamperes, and the master will wake up to the device when it is required. So in that case it is called as a park mode. So using the park mode, the device can be operated for a period up to 2 to 5 years in the case of Bluetooth Classic, and recent development in the technology, it can be operated beyond 5 years, correct, because it consumes very less current, less than 5 microamperes. So that becomes advantageous when it is required for a particular connection. So here the how the events transpire in order to make a connection is shown. The device can start with a standby mode. It can go to the paging mode, where the devices which are not connected earlier, and if they want to form a bond or if they want to associate with each other, they can send a PDU or the payload, and the two devices will exchange their Bluetooth addresses and form a connection. From the standby mode, it can also go into the inquiry mode. As I told now, packets can be exchanged. The Bluetooth receiving address as well as the Bluetooth device address can be exchanged between the devices, and after that they can form a connection, or we call it as a connecting or paging. Once they are connected, they can go into the snip mode, they can go into the hold mode, they can go into the standby mode, or they can go into the transmission mode, in which they can exchange the data from the master, or they can exchange the data from the slave. Slave can exchange the data to the master, and the master can exchange the data to the slave. And from the transmitting mode, again it can go to the standby mode. Similar to that, the Bluetooth low energy, it also have 5 link states. Once you form a BLE network in which each master is only connected to each slave, the packets that I am transmitting, the states that is formed in the network, I can classify them into 5 different link states. How the master and slave communicate with each other. The first state is called as advertising. The device which is interested in making the connection, it starts sending the advertising packet. The second device is called as the scanner, or it is called as the scanning process, in which the devices which are having intention to connect or which are having no intention to connect will receive the packet. They will check the packet. Again, the type of scanning that can be done will be of 2 types. One is called as the active scanning, and second is called as the passive scanning, which occurs most of the time with our Bluetooth speakers. Active scanning, I don't have example for it now, but in the active scanning, the link layer listens to the advertising PDU, which is consisting the information about the nodes, their Bluetooth receiving address, their identity, and it will check if it is interested in connecting. It may ask for more information. More information in the case the security and the other parameters that the scanner is interested in. However, in the case of the passive scanning, the link layer will only receive packets. No transmission will take place from the link layer. Okay, so if you connect your Bluetooth speaker to your mobile phone, the process that is initiated earlier will be advertising. Once the advertising packets are received by the mobile phone, correct, it will start sending the packet to the advertiser, but the transmission is disabled from the Bluetooth speaker. So such type of scanning, it is called as a passive scanning. The third step or the third link state, it is called as initiating, in which the device they form the connection. They start sending the packets from one end to another end, and the fourth state, it is called as connected. So there is a relationship between the master and the slave in the connection state. I can call it as a central, and second type of relationship as a peripheral. One device will act as a central device, and the node or the second device will be acting as a end device, or it is called as a peripheral device. That is a common sense. The master will always act as a central coordinator, or it is called as a central device controller, or different nomenclature I can use for it. And the last endpoint or the peripheral to which it is making the connection can be called as a end device, slave, or it can be called as a node. The fifth state, it is called as the standby state. The sixth link state is called as the park mode, which is removed from the Bluetooth low energy. So in the case of the Bluetooth low energy, the device may complete the formation of network by simply using the advertising channel. Channel in the sense we are talking about the frequency the advertiser has sent in order to make the communication. So generally the advertiser sends the advertiser packet which is having the information about the identity of the Bluetooth device. Second, the frequency at which it wants to communicate, because the Bluetooth uses 2.4 gigahertz frequency and it is divided into 79 channels in the case of Bluetooth Classic and 40 channels in the case of the Bluetooth low energy. So the frequency by which the packet is sent, the same frequency can be used for making the connection, and that's why it is written that in the low energy mode the device may complete an entire communication by simply using a advertising channel. So whatever frequency by which the advertisement has been received, the same frequency can be used for making the connection with the advertiser by the scanner, and the exchange of information can take place by the two-way. So once the scanner receives the packet, it can listen to it and it can make the connection. The process or the device which is going to listen to it is called as a initiator. So the what we say, the advertiser will send the packet. There will be number of devices which are present in the close vicinity. Whoever is in intention to connect to the device will call it as a initiator. So once the network is formed, the scanner will be called as a master and the slave will be called as a and the second advertiser will be called as a slave. The network that is formed will be called as a piconet. So fundamentally you need to remember only major difference between the classic and low energy is that the piconet in the case of classic is comprising of 7 slaves and 1 master. The range is 10 meter for the personal area network. In the case of Bluetooth low energy, the network can range up to 150 meter and the piconet is only comprising of single master and single slave, in which the master is have no bound in making connection with other slaves to form a scatter net. Correct. So in the case of the classic Bluetooth, in the scatter net a common point is shared between the two piconet. In the case of BLE, the master itself will be the common point in order to make the scatter net. So millions of devices can be connected to the piconet formed by the Bluetooth low energy. Type of advertisement, I will remove it from the slide considering the length of the syllabus, but for the sake of knowledge there are two types of advertisement that are done. One is called as the general advertisement, in which the advertiser sends the advertisement to all the devices in the network. Second is called as the directed advertisement. For the sake of again knowledge, if you are already paired with the device and the scanner is having the list in the cache, what you can do, you can turn on the Bluetooth device and select the device and make the direct connection. In that case it is called as the directed advertisement. Okay, so most of you might be using the Bluetooth headset, and in that the pre-paired devices are already present in the list. So once you turn it on, you can directly use the scanner and tap that particular device and have the device connected. Okay, so remember that it is the scanner who is going to choose the advertiser, correct? However, the advertisement can be also directed towards a specific scanner. So the states that are present in the case of Bluetooth low energy, scanning, standby, advertising, initiating and connecting, that we have learned. Okay, you can check these states. One can go from standby to scanning, scanning to standby, and vice versa. We have already studied it. A comparison between the two question can be asked in the examination, might be possible. The technical specification of the two technologies are given, Bluetooth classic versus Bluetooth low energy. Here whatever is given on the right hand side may change over the period of time. Okay, the range may not be fixed. So for example, theoretical distance that is given for Bluetooth classic is 10 meter. In the case of Bluetooth low energy, it is 100 meter, or it is given less than 150 meter. It may change over a period of time. Same is true for the latency, 100 milliseconds that is given here. In the case of Bluetooth low energy, it is given 6 millisecond, but it may not be true. It may be below that. Okay. Security, a point that we have missed in terms of Bluetooth classic, it uses 128-bit security level. Okay. So earlier it was using 56 bit AES algorithm. Now in the case of the Bluetooth low energy, it uses 128-bit advanced encryption system. So whatever packets are transmitted between the node and the master, they are well encrypted and they are not possible to be broken down. Topology, most important thing in the case of the Bluetooth classic, it supports piconet, scatternet and point-to-point communication topology. The advantage of using the Bluetooth low energy is that it also supports the mesh and broadcast topology. So you can consider the broadcast topology as a tree topology in which the master sends the data to all the nodes that are connected to a network. It is a one-way communication which starts from the master and propagates towards the branches that are connected in a tree. Mesh topology, every node will get the data starting from the master that is connected in the mesh. Frequency channels, as I told, these are technical specification, 79 in the case of the classic Bluetooth, and in the case of low energy 40. Okay, so whatever frequency we are having, 2.4 gigahertz or 2400 megahertz, can be divided into number of channels, and a technique which is called as a frequency hopping is used in order to pair the devices in the network. So that is what is called as a data link layer in the case of your OSI reference model. Physical, you connect the sensor. In the data link layer or the physical come MAC layer, medium access code, in which you use different modulation scheme in order to have the connection with the devices that are connected in the network. So the next type of technology that is available in the case of the personal area network, it is called as the 802.15. So what people have done in the United States, Europe and China, Japan, what they did that in the electromagnetic spectrum there is a frequency band in the range of 2.4 gigahertz, which was made free by the agreed standard by the people that it should be free and it can be used for the purpose of in the industrial sector, in the scientific sector as well as in the medical sector. So since these frequency ranges are free, there is a group which is called as IEEE. What they have done, they have exploited this particular frequency band and they have started developing the devices which can exchange the information from one device to another device, and they form a group or the community which is called as 802.15 working group. Okay, and there were companies which sponsored them in order to develop the standards, so that whatever devices I am developing in India, if I take it to another country, it should operate on that particular band. So consensus was not there, so people have started developing their own technologies. So depending on the origin country and other places, there are number of technologies that are available. Unfortunately, not from India. So these are called as the communication protocol, which either work on the bottom portion, that is the physical and the data link layer. So sensors are interfaced, and the media access code, it uses the modulation schemes in order to send the packets from one location to another location in a personal area network. The range is defined as uh, 1 meter to 150 meter, out of which the dash 7 you can consider it as a outlier. Okay, it falls, it is having the range more than 100 meter nowadays, and it can exchange the information up to 500 meter. So it may not be considered in the case of this 802.15 working group standards. So the 802.15.4 working group only determines the bottom portion of your OSI reference model or a stack. It only focuses on the physical and the data link layer, how the packets will be modulated and transmitted from the IoT board towards the top. However, it is the other consortiums to work building the full network solution. So they will only provide you the hardware to make the connection and sending the packets. The packet size may be different. They might be having different types of encapsulation, encryption. It is the remaining consortiums that they need to develop the complete stack in order to transmit the packet to the cloud. So the bands that are available in the unlicensed spectrum, they fall under the category like this: 868 megahertz, 915 megahertz, and 2.4 gigahertz or 2400 megahertz. You need to remember that what example I have taken in the class, how many numbers are there between 0 and 1. Infinite numbers exist. It means that even though I have the frequency 868 megahertz, I can divide it into 868.0102 up to 1, like that, and infinite frequencies I am having in this particular range. How I am going to use it without any interference makes it challenging. So most of the people, they have focused on this 24000 megahertz band, because the antennas that are required, they can be very generic. Their size can be since the frequency range is in gigahertz, the size of the antenna is in millimeter. Okay, so it is very easy to build the devices using this particular technology. So fundamentally, the topology that is suggested by IEEE, it follows the same criteria of IoT. There are number of nodes which I can call it as a reduced function devices, and there are devices which are working as a gateway, and these devices are responsible for tracking the routing table, as well as they are responsible for maintaining who connects to the node and who won't connect to the node. Okay, so broadly I can classify the devices as a fully function device, or I can call them as a gateway, or I can call them as a ZigBEE controller, or I can call it as a what we say the router, like that. The second type of device is called as a reduced function device. Generically, the fully function device is also called as a PAN coordinator, personal area network coordinator, controller, router, whatever I want to call, but it supports any network topology like star, mesh, fully connected, tree topology, like that. However, similarly, there is a second class of device which is called as reduced function device. It only supports the star topology, so it cannot become a network coordinator and only communicate with the network coordinator. So आपको ध्यान में रखना है कि आपके पास अगर दो रास्पबेरी पाई है, तो एक रास्पबेरी पाई आपका फुल्ली फंक्शन डिवाइस बन के कनेक्ट करेगा, और बचे हुए जितने भी रास्पबेरी पाई है उसको आपको रिड्यूस फंक्शनलिटी बना के यूज़ करना पड़ेगा. तो आपका जो नेटवर्क रहेगा उस टाइम पे जो नोड्स रहेंगे उसको आप बोलेंगे रिड्यूस फंक्शन डिवाइसेस, और आपका जो गेटवे रहेगा उसको आप बोलेंगे फुल्ली फंक्शन डिवाइसेस, और दे आर कॉल्ड एज द FFDs. So type of topologies are very important in this sense. One can assume that the star topology is the simplest topology, because we know that all the messages will go to the PAN coordinator, and the PAN coordinator is connected to the backhaul network. So it will know the routing table and it will route the packets properly. So if the packets are coming from the backhaul network, it knows the address of the node where the packet has to be dropped, and that makes the utilization of the network more efficient. Second type of topology is peer-to-peer. So basically it is a mesh topology, but not a fully connected topology, in which there is a master or there is a PAN coordinator which exchange the information directly with the neighbor nodes. In all this topology आपको ध्यान में रखना है कि जो दो slaves है या दो reduce function devices है, they cannot exchange the information directly with each other. वो कभी भी क्या करते हैं, एक डिवाइस से दूसरे डिवाइस को इंफॉर्मेशन रिड्यूस फंक्शन डिवाइस कभी भी कर नहीं सकते हैं. दे हैव टू ऑलवेज गो थ्रू द नेटवर्क कोऑर्डिनेटर और अ राउटर और अ गेटवे और अ फुल्ली फंक्शन डिवाइस. ओके. However, in the case of the third topology that is not mentioned here, which is called as the fully connected topology, the nodes can exchange the information among themselves. Okay, but with the condition that all the nodes should be fully function device. So तीसरे टाइप की टोपोलॉजी है जिसको आप बोलते हैं फुल्ली कनेक्टेड टोपोलॉजी. उसके अंदर कोई भी डिवाइस रेड्यूस फंक्शन डिवाइस नहीं रहता है, सभी के सभी डिवाइसेस फुल्ली फंक्शन डिवाइस रहते हैं, और उसमें अगर एक फुल्ली फंक्शन डिवाइस आपका बंद हो गया तो दूसरा फुल्ली फंक्शन डिवाइस क्या करता है, उसका काम कर लेता है. उस टाइप के नेटवर्क को आप बोलते हैं सेल्फ हीलिंग नेटवर्क. ओके, यू कॉल दैट सॉर्ट ऑफ नेटवर्क एज अ self healing network. It is optimized for the routing table. We'll check it how it works. So the as I told, the fully function device is a PAN coordinator or a controller, or you can call it as a router, or it can call it as a gateway, and you already know the responsibilities of the gateway or the PAN coordinator. What it does, it maintains the devices that are connected below it, as in case of our basic topology. So its role is to set up and manage the PAN, personal area network, whatever below it. It is having a common clock signal which is synchronized with all the reduced function devices in the network. Okay, and whatever packets are transmitted, it has to be go through the PAN coordinator. Most important thing in terms of battery classification, PAN coordinator is always line connected. Okay, or sometimes it is also called as a wall powered. उसको हमेशा आपको line power ही रखना पड़ेगा. It cannot be battery connected. The second device that we are having, which is called as the reduced function device, it may be battery powered. Most of the times it is a battery powered. It cannot become a fully function device. So once you form a network, things are over. There is a fully function device which is line powered, or it is called as a wall powered, and number of devices that are exchanging the information with the central coordinator or the fully function device will be maintaining the device. Which node connects to which network, it will be maintained by that particular fully function device. So here most important thing, the topologies also you should know in case of each technology that we are interested in learning. Here is an example of star topology, in which you are having a PAN coordinator which is a fully function device, reduced function device which is called as the which is having reduced functionality. If I want to exchange the packet from here to here, two RFDs, it has to go to the PAN coordinator. The PAN coordinator is line powered, the RFD is battery powered. PAN coordinator also maintains a routing table. There can be another fully function device connected to the PAN coordinator, but the PAN coordinator which has taken the privilege as a central PAN coordinator will be responsible for connecting all the RFDs through this particular device, that is the PAN coordinator. This FFD can connect to the backhaul network, from where it can exchange the information with the PAN coordinator in bidirectional way. Second type of topology that is supported by 802.15.4, it is called as peer-to-peer technology topology, correct? So it is a mesh topology in which there are number of FFDs that are connected with each other, and there is a central PAN coordinator which is responsible for making the connection between the FFDs. In this case, since it is a peer-to-peer topology or mesh topology, each FFD can exchange the information with the neighbor. Okay, but here the drawback is that if this PAN coordinator is suppose that there is no electricity given to this PAN coordinator, these FFDs will not function properly. So that is the drawback in the case of this particular topology. So let us start with the first topology or the wireless communication technology, which is called as ZigBEE. So generally the ZigBEE earlier it was developed in order to have a small network, what we say, for the residential and the commercial use. So if I want to form a network in the range of 100 meters, suppose that I am going to supermarket and there is a wireless trolley in which whenever the whatever things I buy, automatically the bill will be given to the counter. So for that purpose I can use ZigBEE, but over a period of time people have modified this technology, and nowadays ZigBEE is used in industrial sector also. So the main thing about the ZigBEE is that it is cost effective, power consumption is less, and requires a very less space, or the size of the components in the case of the ZigBEE are very small. So there is a concept in the case of the ZigBEE that it is derived from the word bee. As we know about the bee, it migrates from one flower to another flower in order to have the when it sucks the honey. So same rule is applied in the case of the ZigBEE technology. The packet, it flows through the mesh from one device to another device till it reaches the destination. So since the packet is moving in the complete network, it should be having some router or a common gateway from where the devices can exchange the data. Okay, so we'll check it one by one. So the topologies that the ZigBEE is having is called as star topology, correct? Second is cluster topology, and third is mesh topology. So there are three types of components in this topology. One is called as the ZigBEE controller, second is called as the ZigBEE end device, and third is called as the ZigBEE router. Okay, so definitions are given in the presentation slides, you can read it. So I can deploy 65,536 end devices in any sort of this topology. So this ZigBEE controller is definitely a gateway. It is capable of initiating network functions. Okay, so most important thing, if you observe in this particular topology, the ZigBEE controller is a single controller that is present in all the topologies. So it means that for a ZigBEE network to form, it should only have a single ZigBEE controller. Its prime task is to assign the logical addresses, maintain the routing table under the network in which it is coming, or whatever devices are connected below it. Okay, and it can form a gateway for all the devices in order to exchange the bidirectional data from backhaul network to the this network or this topology. It can also have a ZigBEE router. So we can have this router as an optional router in case of the failure of this ZigBEE controller. This can act as a controller. Okay, and it can also help in multi-hop routing. If this router is connected to another network, I can send the packet from here to here, and I can have a network which is formed as a multi-hop routing network. It can be used for making connection to a large network, and it can also help in assigning the logical addresses. It can also help in permitting nodes to join to other mesh if it is available in the close vicinity. The third category of devices are called as the ZigBee end devices. So we started with 802.15.4, in which we have classified there are two categories of devices. One is called as the fully function device. So in this case the ZigBee controller becomes the fully function device, and the ZigBee end device, it becomes the reduced function device. So it is a simple board, I can say, to which you are going to connect the sensor. It is consisting of limited functionality. It doesn't understand what is routing. Whatever data is gathered from the physical object is converted into electrical signal. At 2.4 gigahertz it is transmitted to the ZigBee controller. Okay, and finally it is the task of the ZigBee controller to maintain the routing table and forward the packet to the network which it is intended to. Okay, so I can have a cluster topology and different types of topology supported by the ZigBee network. Also, as I told, the rule of thumb, the two end devices cannot communicate directly without the ZigBee controller. That is the drawback of the topologies that are present in the ZigBee network. So again, the traffic that is coming in the case of the ZigBee network, since it is developed for the purpose of industrial application as well as the personal area networks, it supports three different types of traffics. जो भी आपका पैकेट जो ये नेटवर्क भेजेगा, सिंस इट इज़ अ पर्सनल एरिया नेटवर्क, जो एग्जांपल मैंने आपको दिया है कि वायरलेसली आप क्या कर रहे हैं कि जो भी ट्रॉली में आपने परचेस किया है उसका बिल ऑटोमेटिकली जनरेट हो रहा है. सो जो डेटा आप भेज रहे हैं वो दो तीन टाइप का हो सकता है. एक हो सकता है पीरियोडिक डेटा. सो पीरियोडिक डेटा इज़ डिलीवर्ड और ट्रांसमिटेड एट रेट डिपेंडिंग ऑन द application. जो भी सेंसर कनेक्टेड है, whether it is for the medical purpose, in that case continuously data will be sent, but the bitrate will be very very low, as we have seen in the case of the topology or the graph. Second, the data that will be sent can be intermittent depending on the application. Again, a good example can be your what we say fire alarm sensor, okay, or moisture sensor which is present in the farm. After 1 hour I will check the moisture level of the soil, and according to that I will take the decision whether to turn on the pump or not. Last type of data is called as the repetitive data with low latency. Okay, but the main parameter which influences the working of ZigBee is that it is having a low latency. So if I want to send the repetitive data, in that case I can use the third type of data traffic which is called as a repetitive low latency data. Okay, here we'll check it in the class. For example, if I am pressing a particular key from the keyboard, I will call it as a repetitive task. So many times it happens that if the network is very heavy or the operating system is jammed, if you press the same key more than 4 or 5 times, it will start displaying after certain time. So that is the example of repetitive low latency. I have pressed the same key again and again, but it takes a little amount of time to get displayed. Even when I change this light comes after some times, and it is displayed on the screen. So I can call it as a low latency. The outcome is not changing very fast. Okay, so the third category of wireless communication technology that is available at the bottom layer, again physical and media access control or the media access level. Another technology that people have developed, it is called as ZWave. It works on the frequency band of 900 megahertz, which is used for exchanging the information. There are people who have sponsored it. The company who has manufactured it, it is again of no importance to us, but for the sake of knowledge, it is a Danish company which is called as Genesis. Okay, they have developed this technology only to control the light. Okay, so light control system they wanted to develop, and for that purpose they had used or exploited the 900 megahertz band. The total number of products that are available with the technology when I have written this content were 2100. This data is wrong now. It is more than 2 lakhs devices that are available on this particular technology. Boards are available. The data that I have taken is from the year 2016 or 15 like that, and it is a very old data. So company who had sponsored in the development of this particular technology, it is called as ZWave Alliance. Uh, Companies include SmartThings, Honeywell, Belkin, Bosch, Carrier, ADT and LG. It means that these company may have the product which are equipped with this technology, and if a technician comes to repairing, he knows all the nomenclature and the specification of the technology, which part to replace. So as the generic rule, this topology will be again consisting of your central controller or the fully function device, as well as your what we say reduced function device. Okay, so here also there are number of nomenclatures or the specification that are given to the nodes. The nodes can have a central device which is called as a primary controller, or it is called as a control device. Okay, there are actually two categories of control devices in the case of ZWave. One is called as the primary controller, which is responsible for maintaining the routing table and association between the nodes or the slaves that are connected to the network. In the case of the ZWave, it follows a mesh topology in which nodes can be also connected or slaves can be also connected with each other. However, the routing table information will be maintained by the primary controller itself. Okay, it knows the hierarchy, how the slaves are connected, at what location they are connected, and what is the topology. It also maintains the IDs of each slaves that are connected in the network. There is again a secondary static controller. We'll check it one by one. Okay, again the second type of controller can be classified into two category. One is called as the, depending on whether it is portable or static, we can call it as a static controller, and second is called as a portable controller. Let me give one example. If you are having a remote control and it is connected to a network, and now you are moving from one place to another place, in that case the type of controller that you are having in your hand, it is called as a portable controller. Okay, the second category of devices that that are present in the ZWave, they are called as slave. So these are the reduced function devices. Their purpose is only to forward the packets, okay, either to a primary controller or either to a bridge, which is acting as a gateway in order to exchange the information from the network. So they are reduced function devices. Most important thing, they cannot communicate with the neighbor, although they are connected, but they cannot communicate with the neighbor unless and until it is instructed by the command by the primary controller. Although they are connected, but there are certain commands, or programmatically you can program the primary controller, which will decide which slave will exchange the information with its neighbor. Okay, the main task of these slaves is to repeat the information. Whatever information is received, it will repeat it, send it to the neighbor, and that neighbor will send it to the bridge from where it will be connected to the backhaul network. These controllers, the controllers can be, as I told, they are of two types. One is called as the portable controller and second is called as the static controller. So as the name suggests, the portable controller can move from one place to another place, and it will be the task of the network to check what is the fastest route available in order to route the packet that is receiving from the network. Okay, since the position is changed, the topology becomes dynamic, and according to that the direction of the packet that we need to send will also change. The second category is called as the static controller. As the name suggests, it will be fixed, and most important thing, uh, although the slaves might be battery powered, the primary controller will be always line powered or wall powered. ओके, सो आपका जो नेटवर्क है उसमें जो आपका प्राइमरी कंट्रोलर है, जैसे ZigBee में था या 802.15.4 टोपोलॉजी का फंक्शनैलिटी में था, इट शुड बी ऑलवेज line powered. So in this case also the static controller will be line powered because it is not moving from one place to another place. Okay, however your portable controller and the slaves might be, or they are battery powered. So most important thing, again the primary controller has to kept always on. These controllers can also have different attributes. Okay, I can configure them to work differently. For example, I can have a controller which is called as the status update controller. Okay, one of the controller that is present in the network can act as a status update controller. So what it generally updates, it receives the notification from the primary controller. Suppose that there is a change in the topology, and if the what we say the topology has changed, the primary controller will send the update to the static update controller, and according to that they will change the routing information, and they will also update the information about the nodes that are present in that network. We can also have the static update controller with ID server. It can also assist in including and excluding slaves from the primary controller. We can also have a type of controller which will be called as a bridge or a bridge controller. As the name suggests, it will be acting as a common gateway for sending and receiving the information from the backhaul network. Okay, it may be connected to Wi-Fi, or as I told, the 802.15.4 only works on the physical and the data link layer. So it can also act as a bridge in order to send the information to the backhaul network, either by using WAN, that is wide area network, or by using a Wi-Fi. In generic way, we'll call it only as a backhaul network. Another category is there which is called as a installer controller. So it manages the network and it looks for the quality of the service. It is not shown in this diagram. So there is another type of controller that should be present in the network, which is called as a installer controller. It checks the quality of the service, the packet that is transmitted from this network, whether they are having good latency, or they are dropping, or there is a loss in the channel. It determines based on the routing table, and such type of controller it is called as a installer controller. Slaves in the Z-Wave topology, they are also having different attributes. Some are called as routing slaves. As the name suggests, they are going to maintain the routing table. Generally, they are not allowed to send messages to another node without the command that is coming from the primary controller. However, they can be used for storing the static routes, how to send the packet from one place to another place. So for example, here 3 slaves are connected, they are forming a network. So if I send a packet from one, so one can determine which will be the shortest path in order to reach to the bridge and finally send the packet to the network. So instead of sending it 2 and from 2 to 3, it is also knowing the static route. It is also knowing the static route, so it can send the packet from to the nearest neighbor once the command is initiated from the primary controller, and it will reach to the bridge, and from that bridge it will go to the network. Second type of slave, it is called as the enhanced slave. So it is having the ability of as a routing slave. uh, in addition to that, it also maintain the real time clock. It is also having the what we say feature of storage. So in the earlier case where the routing slave is there, it simply chooses the shortest path and send the packet. However, in the case of the enhanced slave, it is also having certain memory. If the packet is not if it doesn't receive the acknowledgement from the destination, copy is always present in the memory from where it can be resent to the network. Instead of again taking it back from the primary controller, I can send it to the network since I am already having the copy. Okay, example, you can check it in the slides. I think the example is given of the gas meter. Okay, so as I told, the slave nodes, you need to remember that they are battery powered. Okay, and ZigBee technology, Z-Wave technology, it is used for the uh, home purpose, closed network that can be formed in the local area. A good example is motion sensor in home. Okay, so I have removed most of the slides. These are not the original slides. Wireless art will take it in the class. I will stop here today. Any difficulty or doubt? So I will upload this recording on YouTube. Okay, it will be available from tomorrow. Let me take the attendance now. Okay, we'll stop here. I don't think you are having any difficulty. Anybody from you?